Today we're going to be talking about calculating the circumference and arc length in a circle. So the first thing that we want to talk about is identifying the different parts of a circle. So if I have this circle here, we already know that we have a center, and from the center comes the radius. So that will be our radius. In addition to our radius, we also have, passing through the center, a specific chord called the diameter. And then the distance around our circle is called the circumference. So in order to calculate that, we're going to either need the radius or the diameter. So here's the first formula that you're going to want to write down. So circumference, C, is going to be equal to 2 pi r. Or if we're given a diameter, we can also calculate the circumference by taking pi times the diameter. Again, C is circumference. R is radius. And D is diameter. If we know those measurements, we are able to quickly calculate to find the circumference of a circle. We also want to make sure that we note that pi is going to be used in our answers. The most exact value that we are able to use is pi, so we want to recognize that we can potentially leave our answers in this format, unless we're told to round or provide decimal values. So let's go ahead and do some of these examples here. The first one is, what is the circumference of a circle if its radius is 7 centimeters? So here again, we are given the radius. So I know I'm going to be using this formula here, and I will be substituting in place for the radius. So circumference is going to be equal to 2 times pi times 7. So this will give me 14 pi centimeters. Again, noting that we can leave our answers with the pi there, and that's the most exact value. And then make sure you do not forget your units. So here we're talking about centimeters. In example number 2, a circle is inscribed in a square with 10-inch sides. What is the circumference of the circle in terms of pi? So I kind of want to draw that here. Here's my circle. And then I'm going to roughly put a square around it. The sides of my square are 10. And since it's a square, all the sides are the same. If I had drawn my picture better, we could see that the diameter here is going to be the actual length of a side. And that would be 10 as well. So if I'm going to calculate the circumference, I could do one of two things. I could know that the diameter is 10. I could also figure out that the radius is also 5. So I could use either of those. In this scenario, circumference is again equal to 2 pi r. So is equal to 2 times pi times 5, which is going to be equal to 10 pi inches. We could have also used the other formula, pi times diameter, given that we already had the diameter 10. So that's that example. All right, arc length. Arc length, again, we are referring to a portion of the circle's circumference, so just a particular part of it. So I don't want the total circumference, but I am going to have to use the circumference formula in some way, shape, or form to figure out what our arc length is. So arc length, here's our formula. So we're going to note arc length with AL. This means arc length. So the arc length of any portion of the circle can be found like this. We're going to use A, which is a degree, and that's actually going to represent the angle given. The angle that we're given, which will coincide with the arc. And that is always going to be over 360 times our circumference formula. And our circumference formula, again, if you recall, is 2 pi r. And again, r represents our radius. So we're going to go ahead and apply this formula to these examples. So it says, what is the length of arc PQ? So I'm looking for this arc here. I'm given a central angle of 135, therefore I know my arc is going to be 135 as well. So I'm going to write down the formula. Arc length equals the angle, or the arc measure, over 360 times 2 pi r. And here, all I need to know is which values I'm supposed to be substituting in. So far I need the arc measure and the radius. And like I started out saying, I'm given a central angle, therefore I know what the arc is going to be. In this case, it's going to be 135 degrees times 2 times pi times 12. Now you're going to have to just go ahead and use your calculator to plug this in. I can certainly run you through how to do this, but you want to make sure that you can do it independently. Arc length is going to be a total of 9 pi units. So go ahead at this point and put all of this into your calculator, minus the pi symbol there, because that we're just going to attach at the end here, and see if you also get 9. In example number 2, again, we are asked for what is the length of the radius. So if they're asking for a different component of the formula, again, I like to write down my formula that I'm using, just so that I know what I have and what I can plug in. Right here, they've given me an angle, so I know that I'm going to be plugging in for an angle here. So here in this scenario, 80 over 360. And then the question is, what is my radius? I don't have a given radius, so I'm going to have to write 2 pi, and then we're looking for the radius r, equal to, they must have given me my arc length, which arc length, 32 pi units, 32 pi. Now I'm going to have to do some calculation here in order to figure out what I have. And in the end, after I do some magic with my math over here, it's going to end up being that my radius is equal to 72. My first recommendation for you is to make sure that you simplify this portion right here. See what that gives you. And then once you've done that, go ahead and continue to use your algebra to solve. But I'd like for you guys to start doing that a little bit on your own so that you can check your answers there. If there are any questions, you're more than welcome to ask us via WebEx or individually by email.